students? Can able to hear my voice, ma?
Yes, ma'am.
Yes, ma'am.
Yeah. Good morning. I think those who are in biomedical and instrumentation, have you all joined, ma? In biomedical?
Yes, ma'am.
Yes, you have joined. We have reached only 49, 50. How many of you in this Python, ma?
Ma'am.
How many of you in the Python? Okay.
Ma'am, total 60 members, ma'am.
Yeah. Then why some of them were left? 3 participants.
No, ma'am. Actually, Abhita ma'am, suddenly Zoom was closed, ma'am.
Oh, okay. I think ma'am leave the meeting. That's why. Okay.
Yes, ma'am.
Yeah. Okay. Is it visible to you, ma?
Yes, ma'am.
Yes, ma'am.
Okay. So now I told you today there will be a question session for you people. Okay. Still we need not reached the participants. Only 66 participants are there. You all know the timings, na? Till 12 to 1 you have the class.
Yes, ma'am.
Yeah, Tyagi is there. Register number 48, Tyagi is there. Harshavardhan, what's your doubt, ma? You have raised your hand, Harshavardhan.
No, ma'am. Like you asked the members who are from Python, so at that time I raised my hand.
Okay. Yeah. Still 68 participants are there. Why? See, you people remember the attendance. We were cross-checking in reports of Zoom. Some of them were giving attendance, but not attended the classes. So what if Jagan, whether Jagan is present here, ma? I think he is absent for
Present, ma'am.
present. Jagan, but you are absent for the previous classes, no? Jagan,
Yes, ma'am.
why?
Network issue, ma'am.
Yeah, yes, traffic network issue. Where you are? Jagan,
Yes, ma'am.
where you are staying now?
Home, ma'am.
Yeah, tell me the place. I'm asking.
It's,
Jagan, which place, Jagan?
Arakonam, ma'am.
Arakonam. Arakonam network traffic is there. I'm hearing some sounds from your mobile. Jagan, we crossed 3 classes. I have completed the comparison, architecture, and pin diagram memory. When I'm start talking, I think it will be new for you. So people try to understand, attend the class regularly, then only you can understand the flow of the class. Are you clear? Yesterday, I have put up the PPT in our LMS and I ask you to people to visit. I don't know how many of you have seen that. Still 73 is there. Why? What happened, ma? Actually, the people thought the last hour class is suspended. Okay. Now I will ask some questions to some students. Then we will move on to the topic. Oh, okay. Still, it is getting increasing. Okay. Now, register number 15. Bhavana.
Yes, ma'am.
Tell me, what is Harvard architecture?
Ma'am?
Harvard architecture.
Yes, ma'am.
Bhavana?
Yes, ma'am.
Yeah. What is Harvard architecture? Hmm? Why? Okay. Unmute your. Mute your audio, mom. Mute your audio. Sandhya. Sandhya M. 71. Register number. 71. Sandhya.
Yes, ma'am.
Yeah. Tell me what is Harvard architecture. Yeah. You people not prepared for the test. Question session. Hmm? I'm asking very simple question.
Ma'am, register number 10, ma'am.
Register number 10 can answer. Yeah. Tell me 10.
Attendance, ma'am.
Attendance I'm not taking. The question session
Now
is
only
going
I
on.
came to
You
network
came.
problem.
It's not a problem, ma'am. Tell me what is Harvard architecture.
Yeah.
Ayyo. Tell me.
Ma'am, I don't know, ma'am.
You don't know. Okay. You people listen. Whatever I have uploaded in LMS, please kindly go through. 2 days holiday is there. Jagan, you are absent for the continuous classes. Santosh Reddy is present today. Mute your audio, Anshri. Yeah. Santosh Reddy is present today. Tyagi is present today. Tyagi? No. Okay.
Yes, ma'am.
So,
Ma'am, present.
Tyagi is present.
Yes, ma'am.
Yesterday you are present to the class.
No, ma'am. Yesterday I was absent, ma'am.
Absent. But still some of them were giving proxy attendance for you. Hmm? You are absent. But for Tyagi, they gave the attendance. See, you people remember the report is generated in Zoom. At what time you have been in the class will be everything is generated. So please people don't do this kind of activities. Yes, clear, ma? Okay, today I will directly go on to the class. Please kindly go through the PPT or else I have to go give any recap for you people. Recap is needed or directly we go to the new session. Shushant, tell me register number 19, Shushant.
Ma'am,
Yeah, tell me recap is needed or we directly go on to the today's session.
Once again, repeat once.
I have to explain the previous classes important points. Recap is needed or else I have directly gone to the topic. I didn't ask any question, man. Still you are thinking. Listen, people, I will once again highlight the points and then I will move on to the topic. Okay. So the first important question is comparison of processor and controller. We have already discussed. Okay. The main difference is processor, we have only ALU unit. Okay. This ALU unit we have, but controller, all the chips together embedded on a single chip along with ALU, timer unit, A to D, D to A, onboard memory, everything we have embedded on a single chip. So that is the main difference between microprocessor and microcontroller. Microcontroller, one chip is needed sufficient to connect with the other system, but microprocessor we need so many chips. So according to this microcontroller, we have so many advantages. What is the first advantage now? Cost wise, microcontroller is cheap because only one chip is needed. Then execution time is fast. Okay, because everything is embedded on the one chip. All the reasons will be same thing only. So execution is fast, cost will be very less. And one among another important point is we have a Harvard memory architecture. That's I have asked Bhavana, listen to the point. Harvard memory architecture now, what does that means? Program memory and data memory, we have a separate memory. So if I want to access program, it is easy to access program. If I want to access data, we can easy to access data. So how we were segregating the component is easy for us to access. Na? The same way they have it. But we have a microprocessor, we have von Neumann architecture. Von Neumann architecture means we don't have a separate memory for program and data. Everything is having a single memory. Okay. And microprocessor and microcontroller, another important difference is in microprocessor, we don't have a onboard memory, but microcontroller, we have a onboard memory. Okay. This is the difference. And then we discussed about the pins of 8051. Okay, we all discussed all the pins. So totally 40 pin structure, 32 pins they allocated for ports. How many ports are there? 4 ports, 32 pins, supply 2 pins, oscillator 2 pins. This and all we already know. Reset 1 pin. ALE means what? Address latch enable is 1 pin. Apart from that, 2 pins we were mentioning now. This 2 pin mainly to access the external memory as well as internal memory. PSEN, this is program strobe enable, is mainly to access the external memory. This is EA, this pin is mainly to access the internal memory. When EA is 1, it will access the internal pin. When EA is 0, it will access the external memory. Okay, now this we have discussed. Then architecture. So we have seen 3 important questions: comparison of microprocessor and microcontroller, pin diagram, then architecture we have discussed. Are you clear? Then we have seen the registers. Actually, by seeing the previous classes, I am getting lot of answers. If the question is asking to particular students, they can't able to answer. Subbulakshmi, register number 85. Subbulakshmi?
Yes, ma'am.
Yeah. Can you able to tell memory capacity? I think I have opened the page for you reference. Yeah, tell me what is onboard memory capacity. Tell me. Onboard. No answer. Vijay, register number 93, Vijay.
Yes, ma'am.
Yeah, tell me the memory capacity of 8051, ma.
Tell ma'am.
8051 memory capacity. I have opened the screen for your purpose. At least you may tell me by seeing the PPT. Tell me. Vijay? Yes, you people were not listening the class now. How can you understand, ma? 73 Saranya. See, people who have asked, I have the question, they're not answered. Please ensure that the question will be asked intermediate of the session. While I'm taking the classes, I will stop and I will ask you the questions. 73 Saranya.
Ma'am.
Yeah,
4 KB, ma'am.
4 KB, what is that 4 KB?
ROM, ma'am.
ROM, okay. And then that memory is called as which memory? Internal memory. At least by seeing the PPT you can tell, ma. Huh? Charanya?
Ma'am.
Tell me.
Mm.
703 Monica. 703 Monica, I think you are absent for previous class. Why,
Yes,
ma? Same network issue for you.
Yes, ma'am. Heavy rain, ma'am.
Heavy rain. Okay. See, Mogana Priya. Register number 53, Mogana Priya. Not 53 is not a Mogana Priya. I'm sorry. Yeah, Mogana Priya.
Yes,
Tell me at least memory organization in 8051. Yesterday I have spent 1 hour of time and it was the first hour, 8:30 to 9:30 I started and I have explained you what is internal memory, what is external memory. Vijay? Vijay, yeah, can you able to tell now? Why you muted your... yeah, tell me. Why you muted? 4 KB ROM. 4 KB ROM?
Program memory.
Program memory, okay. 4 KB na how many locations, ma? 4 KB na how many locations?
4096, ma'am.
96 memory locations. The program memory will be there. And RAM, how many memory? How many memory locations, ma? 256.
256 bytes.
Yeah, 256 bytes, 256 memory locations are there for data memory. So listen well. Please kindly mute your mic. I'll repeat. My memory having 8051 having Harvard memory architecture. What does that means now? It have a separate program memory and data memory. So my speed of the system will be very high comparing to the processor. So in internal memory, the capacity is for read-only memory is 4 KB, program memory, and RAM. RAM means random access. I have a both option of reading and writing from the memory. So that is 256 bytes. That is 256 bytes means 00 to FF. Can you understand? That is data memory. So here this is internal memory. External memory, how many address lines in 8051? 16 address lines are there. 16 address lines means memory, external memory capacity will be decided by 2 power 16. So 2 power 16 means what? 64 KB. So 64 KB data memory will be there. Okay. So similarly 64 KB ROM memory will be there. That is program memory will be there. So in the 64 KB, 60 KB externally purely they will allocate and 4 KB only they are transferring to the internal. So this is you have to understand. Can you understand? So how they are transferring to the internal now? The pin which is used in 8051 is EA pin. So the EA pin is logic 1 means it will access the internal memory. If EA pin is 0 means it will access as a external memory. So that is the only thing. So always remember 8051 Harvard architecture. Separate memory, program memory and data memory is separate. That's why internal also program and data memory separate. External also program and data memory separate. External 2 power 16, 64 KB, that is 65,536 location allocated for the external memory. But while I'm going with my internal memory, it is 4 KB only, and RAM is 256 bytes. 256 means 00 to FF. So only 8-bit address lines will be in the RAM memory. Okay. So this we have explained in the previous classes. So people listen, I'm not satisfied with your answers. So once again, the question will be there till what I taught on yesterday portion. And now, please listen the topic. It's very important question. Ports. Okay. Here, whatever the topics in the first unit, I can simply tell a comparison of microprocessor and microcontroller, architecture, pin diagram, memory organization, ports, timer and counter, then serial communication. Only less topics are there. Can you understand or not? So we can eat, it's not a problematic paper. It's a completely theoretical paper. So only thing is, if you understand this topic only, you can be able to write, because your assessment is based on quiz, as well as even writing a part B question is very easy. Writing the quiz will be very difficult. I think some of them have meet that arrear exams. So you have 4 options, but you have to identify the correct options. So you have to know the entire thing very well. So please understand that your internal will be calculated only by this quiz, assignments and internal exams. That is also probably as a quiz only. So you have to know at least the you have to know, understand the concepts well. Then only you can able to answer the multiple choice question. Are you clear? Now we will today, our entire session is about ports. Okay, please listen. How many ports are there, ma? 4 ports are there. Port 0, port 1, port 2, port 3. Are you clear? Okay. Now, when you see this diagram, you see my port 1 doesn't have any function. It have only a single function. That means it will act as a bidirectional port only. It doesn't have any alternative function. That is port 1. When I move on to port 0, my port 0 will serve as a bidirectional input output port. Along with that, it have a multiplexing of address and data line. So it serves 2 purposes. One purpose is what, ma? Bidirectional, and another purpose is what? It will act as an address and data pin. When I move on to port 2, it will also have 2 functions. What is one function? It will act as an bidirectional port, as well as address line is also in port 2. So when you have to understand very well, my 8051 having 8 address lines, 8 data lines and 16 address lines. So my 8 address and data lines are multiplexed. It's one of the important question, why address and data lines are multiplexed? Because we are using separate 16 lines dedicatedly for address and separate 8 lines for data lines. So totally in my maximum capacity of my bus will be 24 lines. But here within 16 lines, I am carrying my address as well as data. So the number of bus utilized will be less in 80. The number of bus will be less is utilized by multiplexing address and data. What is the main advantage means address and why address and data bus are multiplexed now to get the less number of address and data lines. Can you understand or not? Then just move on to port 1. Port 3. Port 3 also, it will serve as a bidirectional port, and then along with that, it have some other function, that is serial, RXT, TXT, then interrupt timer function, then read bar and write bar. So here port 1 only will serve as a simple IO port, input output port. The other 3 ports have a 2 function. One is it will act as a simple IO port. Along with that, it will do an alternate functions. Are you clear? Sneha, please. Sneha, why you raised your hand, ma?
I'm sorry, ma'am.
Oh, you are checking whether all your buttons are working proper. Okay. Sneha, tell me, which port will serve as a single purpose? Which port is serving as a single purpose, ma?
Port 0, ma'am.
Port 0. Okay. All other ports have a alternative purposes. Can you understand?
Yes,
It will
yes,
it will act as an very good. Yeah, mute your audio, ma. It will act
Thank
as
you,
an
ma'am.
it will act as an input IO port. Along with that, it have some alternative function. Can you understand or not? But you people, you have only a single function. You are supposed to study. So you have got a long back, and you people are entering into the online class. So at least try. You are taking only 4 hours of class. So you people try to listen what we were saying. Okay, you can't understand what we are putting some effort, because in class we have a face-to-face communication. Whether you are listening and all, we will understand. But here you people have to listen. So open your ear and listen. That is very important. Okay. Now we are going to see about all these ports. Port 0, port 1, port 2, port 3. Okay. So each port has how many pins, ma? 8 pins. So totally 32 pins dedicatedly allocated for these ports. So all ports are bidirectional. Bidirectional means what? That particular port will act as an input port as well as output port. What is input port, ma? My port will send the data to microprocessor. That will act as an input port. What is output port now? Microprocessor will send the data to the port. That will output port. So receiving as well as transmitting, that the port can serve. So all the 4 ports is having, all the ports are bidirectional port. Okay. Then next one is we are using D-type output latch. Have you heard this word latch? I think I have to ask this question to the people I have taken the class for you. Jay Prakash, are you present? Register number 51. 51, register number 51, Jay Prakash is absent today. So, okay, register number 27, Divya Darshini. Divya Darshini. Yeah, tell me what is mean by latch? Have you heard about this word? While you are studying digital logic circuits, I am your course coordinator, or Sujata ma'am? Huh? You only, then you have to say. D-type is what, ma? D-type flip-flop. Have you heard about this word? Flip-flop. We have studied the 3 flip-flop. Sorry, 4 flip-flop. SR flip-flop, JK flip-flop, D flip-flop, T flip-flop. 4 flip-flops are there. But here D-type flip-flops is nothing but latch they have given. What is the difference between latch and flip-flop now? Latch means without clock pulse it will work. Flip-flop with clock pulse it will work. But both will be same. Can you understand? Okay, so here all the ports are connected with the flip-flop. You all know microcontroller means it is not a new one. Thousands and thousands of gates, thousands and thousands of memory units, thousands and thousands of latches and flip-flops are embedded on a single chip. So this all fabricated as a controller. So the basic component already you have studied. Now while you are moving on to the controller concept, we just go back and we were saying what we learned, we are just trying to correlate with the subject. Okay. Now, have you able to see in this, ma?
Yes, ma'am.
Yeah.
Yes,
Okay.
ma'am.
Yeah. Okay. Now you mute your mic. I'm just going to put some applications of the ports. I have seen this is my actually this is a Proteus software. We will do it in the lab, ma. Actually, we will do it in the lab. Okay. Here I have connected my port to. This is nothing but a microcontroller chip. You have seen I have connected to. This is my 7-segment LED. My 7-segment LED is displaying 1, 2, 3, 4, 5, 6. I think you have studied this in your microprocessor. The 7-segment LED, na, each segment is denoted as A, B, C, D, E, F, G, and the last point is nothing but a decimal point. So here you see I didn't need any interfacing element. I am directly connecting my port 2 with my 7-segment LED and automatically it is displaying. So this is my microcontroller chip. You have seen port 0, port 1, port 2, port 3. So port 1 is only the port which doesn't have an alternative function, but all other ports having an alternative function. So this is for oscillator pins. These 2 pins are oscillator pins, and this is nothing but a reset pin, and this is nothing but a, I told you to access all related to the external or internal memory. So we will see how it is displaying. Actually, the concept of ports I will tell you. First, I will show some applications. Then you can understand how these ports are working. Can you understand? I think you people, can you able to see this slide? Now this is my 7-segment LED. So in the 7-segment LED, I have seen this. All the segments A, B, C, D, E, F, G. Okay, Nandini, you tell me, ma, this we have used which configuration? Common? Hey, it's very nice to switch on your video, but you have, okay. Number 1, ma, number 1, Aarti. Number 1,
Yes.
Aarti, yeah, tell me. This is what, ma? The symbol is what?
Diode, ma'am.
Diode. Okay, but it is a LED, light emitting diode. Okay. Now, which configuration they used? Common cathode or common anode?
Common cathode, ma'am.
Why? Why it is common cathode? Why it is common cathode, ma? Because all the cathodes are connected. Yeah, mute your audio. Good. All the cathodes are connected and it is grounded to a point. So there will be a 2 configuration is there in 7-segment LED, common anode or common cathode. So here you see I have taken the first LED A, then B, then C, then D, E, F, G, and this D is decimal point we were seeing. So decimal point is this DP. So normally here we were not considering the decimal point. I am just want to glow 1. 1 means I have to switch on what, ma? B and C. Can you, sorry, 2 means what? A, B, G, E, D. So depending upon the number, the particular 7-segment portion will glow. Okay, so now we will go on to the slide how we were writing. You just see the same thing. I have written well. Have you seen? If I want to glow 0, what are the segments I am glowing, ma? A, B, C, D, E, F. So what I have to put, this is common anode. So common cathode. So if I want to glow this LED, my anode should connected to 1 means the element will glow. The anode element is 0 means that particular segment will become 0. So the thing is, if I want to glow the element, I have to put 1. If I want to switch off the element, I have to put it as a 0. So you just see which port I have connected, ma? Which port I have connected? Port 2.0, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6 and 2.7. So each port is connected to the particular segment. I think you can see in this diagram. Each port they were seen A, B, C, D, E, F, G and DP. So whatever the value which is transferring from my port to microcontroller, there it will glow. So here you see that I want to glow this 0 now. I have to glow. I have to put 1 for what are the elements? A, B, C, D, E, F. 1, 1, 1. So now you tell me the value. How will you identify the value? 0, 0, 1, 1 means what is the value in hexa? 3. 1, 1, 1 means what? F. So I have put 3F. Now putting 1, which element I have to glow? B and C. So B and C alone 1. The remaining all values are 0. So 0, 0, 0. What is my value? 0. 0, 1, 1, 0. What is this value? 6. So what is my value? 0, 6. Now I want to glow 2. 2 means what are the element I will put? A, B, then E, D, G. A, B, E, D, G. So that element alone I have to connect, put 1. The remaining element 0. So 0, 1, 0 means what is the value? 5. 1, 0, 1, 1 means what? B. So 5B. Can you understand? So similarly, using the 7 segment, I'm just writing this value to my port automatically. Actually, I'm not explaining in programming mode. Can you understand? Programming is you have to know the instruction set and all, but you know what is the applications of the ports. So ports, by simply assigning 1, the value, how it is working, by simply assigning 0, the particular segment is 0, that means off. The particular segment is not glowing. Can you understand? So I think this is one of the application. The next application I can see, actually we people are electrical engineers. We always focused on motors. So you just see, I have connected my microcontroller with motor. It is a simple DC motor. Here I have connected, this is nothing but a driver chip. Only to energize the motor only I have used this driver chip. Okay, so it's not an interfacing chip, it's a driver chip for motor. Okay, now can anyone tell how I can rotate my motor is rotating in clockwise direction. If I want to reverse the direction of the motor, what I will do as an electrical engineer? Yeah, anyone can tell? Number 19, register number 19.
Yes, ma'am.
Yeah, tell me, how will you change the rotation of the motor? How will you change the rotation of the motor? You don't have idea? Okay, mute your audio. Anyone can know, ma? Please kindly unmute and tell the answer for this.
By reversing the voltage.
Yeah, very super. Who have told the answer, ma?
Kritika.
Yeah, very good. So what Kritika said na, by reversing the terminal, the motor will rotate in the reverse direction. That is the concept we were using here. What is the working algorithm I have put now? EN. Actually, there are 2 pins are there. One is enable pin and these 2 are the input pins. And these 2 are the output pins where I connected the motor. Similarly, this is my enable pin EN. And this is my input of the motor, there where I have connected the output of the motor. So EN enable should be always high. So you just see, if I want to rotate my motor, input 1 should be high, input 2 should be low. High, low means here nothing but high means logic level 1, low means logic level 0. So if I connect input 1 to 1 and input 2 to 0, my motor will rotate in a forward direction. If I want to reverse the motor, okay, what I will do? My input 3 would be connected to low and my input 4 should be connected to high. So automatically my motor direction will be reversed. I think you can see this image. One motor is rotating in forward and another is rotating in a reverse. And after a time delay, see, once again the first motor is rotating in reverse and the second motor is rotating in forward. So it's keep on changing the direction by writing the logic. But this is the logic how to rotate the motor in forward and reverse direction. I think you have seen This is nothing but supply to the driver circuit, that is to the driver chip, and this is ground. We all know this is a supply and this is ground. So the logic level, it is very easy to control any motor by giving the reversing the pin, by reversing the values in the pin, we can reverse the rotation of the motor. Okay, now can you able to see LED green? I think it's seen that this LED is on and off. Okay, this LED is on and off. That means my LED is regularly on and off. So definitely I have to give the time delay. Due to the time delay only, my LED is on and off. So we all know we have a program, that subroutine program we have to write to switch on, that is to on and off pattern. We have to get it in LED. We have to go with the subroutine. Okay, now you can see this. There is two logical level of connecting my LED. Okay, the first logical level is I have connected my anode to the port 2.0. If I connect anode to port 2.0 means I have to give 1 to this pin. So 1 to this pin means automatically this LED will glow. Now you come to method 2. So method 2 means what? Means here by giving 0 to the pin. Can you understand or not? If I give 0 to the pin, because which is connected to the port 2.0, cathode is connected. So when my LED will glow, anode should always connected with 5 volt, that is supply voltage, it will connect. And whenever port 2.0 will give 0, then only it will off. So we have a two kind of on and off. Can you understand or not? So here also they followed two methods of getting on and off. So all are depending on port values only. You try to understand my port is high or my port is low, depending how we are interfacing the motor, or it is a LED, or it may be as a 7 segment, whatever may be, depending on that only it will work. Is clear? You understand the applications. We have seen 3 applications. One is just the 7 segment pattern we connected with port 2. Or you may ask, ma'am, whether we have to connect with port 2.4. It's not a mandatory. We can connect with any port, whatever may be the port. We have to assign that value to the port. All the port will act as a bidirectional port. It will act as an input port as well as it will act as an output port. So that is not a problem. So in another port we have connected a DC motor, and another port we have connected a simple LED. Okay. Now we will see the port 0 configurations, how it is working. So to understand this port 0 configurations, once again. Input mode and output mode, how it is working. I told you all the ports have how many bits? 8 bits it having. So input port means from port to processor, how it is transferring the data. Output port means from processor to port, how it is transferring the data. You just see, if I want to configure as a 1 means it will act as an input port. If I am configuring as a 0 means it will act as an output port. You just see here in this pattern, I'm from input to I'm transferring my data to bus. You just see 1. 1 means automatically it will connect it to the bus, and there they will get the voltage, and automatically this is 1 means this is 1. So we hear high voltage is this is fit. So automatically the device will off. So whatever may be, the input is 1 means this will transfer to the internal bus. When I'm coming to the output port, 0 volt. In the 0 volt condition, for example, see, I have to read the 0 from this bus. So from 0 from this bus, for what I will do, my 0 will connected with the FET. So in that low voltage, what happened? The device will become on, so automatically it will go to the low resistance path. My output will connected to the ground, so the current will flow like this and will act as an output port. So 1 means it will configured as an input port high, and 0 means it will act as an output port. So this diagram illustrates. Just I will repeat. in input port 1, I'm giving 1. So 1 means my data will be transferred to internal bus. So while I'm transferring my data, this device is off. So automatically my transfer will be go through this way. Can you understand or not? My data won't flow to here because the device is off means what? The device is open. You all know we have only two conditions. The device is on, the device is off. The device is off means the current won't take that path. Can you understand or not? The switch is open means what? When the current will flow, when the switch is closed. So this won't take this path. Automatically it will connect with the internal bus. When you come to the second condition, here my device is on. So the device is on means what is my port 0? Port in my internal, it is 0 means automatically the device is on means my output voltage will be connected with the FET. So 1 means it will configure as an input. Okay. Input means what? I told you that very well. My port will send the data to internal bus. Output means what? My internal bus, that is CPU, will send the data to port. Okay. Now we will see all the ports in detail. Yes, students, please listen. This is one of the important question. How I told you, architecture is very important 12 mark question. Similarly, explain the ports of 8051. That is also one of the important question. So there are 4 ports are there. So we try to at least cover 2 ports today. Yes, clear. So the time is 20 minutes are there. So we people will see how the ports are there. You have to know how ports have how many bits? 8 bits are there. So now you please try to understand. First, I will tell you the port 1, internal structure of port 1. We have only 3 parts: latch, delatch, output driver. See, this is delatch. Latch means what? It's nothing but a flip-flop only. But the difference between latch and flip-flop is we are not giving any clock pulse. That's why we are saying latch. That is which type latch we are using? Delatch. Okay. And this is output driver circuit. And this is nothing but input buffer circuit. Okay. Can anyone tell the D flip-flop truth table? Did you remember? Can anyone remember? No possibility. Okay. I will tell. If D is 1, Q is 1. If D is 0, Q is 0. Okay. So that we used to say, so D equal to 1 na, Q equal to 1. If D equal to 0 na, Q equal to 0. So remember, what is Q bar? The complement of Q is Q bar. If Q is 1 na, Q bar is 0. If Q is 0 na, Q bar will become 1. So my port 1 having only 3 important component: delatch, output driver, then input buffer. See here, this is one, this part and this part, that is input buffer. Okay. Now I will explain the operation. Okay. Now you first, why I am explaining port 1 now? We all know port 1 doesn't have any alternate function. It will simply act as an bidirectional port. Bidirectional port means what? It will act as an input port as well as output port. So we were checking 2 commands, write as well as read. Okay. What is write operation and what is read operation? Write means processor to port. Okay. Read means what? Port to processor. Are you clear this value? Write. I will write my value. My internal CPU bus will transfer the data to port. Can you understand? Read. What is read operation? What is read operation? My port will, from port, the CPU bus will read the data. Can you understand? So please make it as a hint. Write means processor to port. Read means what? Read means what? The vice versa. Port to processor. Are you clear? Now I am going to explain the write operation. So please listen how it is working. Okay. Now I am going to, in my internal CPU, how many parts? Only 3 parts. What are the 3 parts? Delatch, okay, output driver, input buffer. Okay. Now internal bus, I am giving 0. D is 0. I told you already the truth table of D. D is 0 na, Q is 0. D is 1 na, Q is 1. So here D is 0. D is 0 means what is Q value? 0 only. So Q is 0 now. What is Q bar value? 1. Okay. So here Q bar is 1. So automatically this portion will on. Automatically my VCC will on means what? The device is closed. The switch is on. Automatically it will be connected to the ground. So the port 0 will get 0 output. So that is what I am giving 0, the same 0 I will get it in my pin. Can you understand? Now again I am going to write 1 in my CPU bus. Now I am writing CPU bus is 1. So D is 1 and what is my Q value ma? 1. Because D is latches, delay latch, whatever I am giving in the input, the same output only I will get. So D is 1 and Q is 1. So Q is 1 and what is Q bar value? 0. So Q bar is 0 means this device is off. So automatically VCC means what? Supply. Supply will connected to port 1. Now what is my port 1 value? 1. So remember, it's not a port 1. One pin of port. Can you understand or not? How many pins are in port 1 ma? 8 pins are there. I am explaining with only one pin. So don't imagine this port pins. It's not relevant to all. It is not relevant to all pin. So for when you take port 1, behind the port 1 pin, this circuit will be inside the microcontroller. Can you understand? When I'm designing one microcontroller, I'm having thousands of flip-flops, thousands and thousands of gates. Everything is embedded. So you have to understand the concept very well. So I'm writing D equal to 0, Q equal to 0, Q bar is 1. Then automatically this will be connected here. This port 1 is 0. So internal CPU writing 0 to the particular pin of port 1. Can you understand? Similarly, if I'm writing 1, the device is off. Automatically this will be connected to the pin. Okay. Now you come to the next one. This option is what ma? Read. Okay. Read means what? I told you, port to processor. So my content will transfer from port to processor. Are you clear? Okay. Now I'm going to read from this port. Okay. This is 0. Okay. This is 0 means, so what happened now? Here this device is off. Automatically whatever the content here, it will reads here. Can you understand or not? This is nothing but a buffer. So whatever here, it follows. Okay, just like input, whatever I'm giving the data, 0 will be read out by the internal CPU bus. Okay, you may ask why it is off. Okay, why it is off ma? I told you the two conditions. Input port na, I have to give 1. Output port na, it have to give 0. So input port na, this D should be 1. This is 1 means what? Q is 1. Q is 1 and a Q bar is what? 0. So the device should be always off. Can you understand or not? Then you come to the next point. I want to read 1 from the pin. Again the same concept. So now my pin will act as an input pin. Here in the previous case my pin will act as an output pin, and here my pin is acting. So I'm giving D equal to 1, Q equal to 1, Q bar 0. Leave it. So here the device is again off. Then automatically whatever I'm giving the data, that will be given to the internal CPU bus. So this is my port 1 configuration. Are you clear? This is my port. Don't confuse on this. This is I copying. It's got port 0.6. Actually this is port 1 operation only. Is clear? Have you understand how the port 1 is working? Very simple operation. Port 1 consisting of 3 important blocks: D latch, okay, output driver, and input buffer. So depending upon that, how it is working, writing and reading. Writing means CPU to port. Reading means what? Reading means what? Pin to CPU. Okay. Now, students, I think now actually while I'm explaining, I'm keep on talking. Bharat, register number 14, Bharat. Bharat?
Yes, ma'am.
Yeah, Bharat, tell me port 1 I am explaining now. Okay, what is the read operation I have mentioned here? What is read operation, ma? Read means how my data will flow.
From external.
Read means what? I told you two operation, reading, RD, read, WR, write. This is not a new thing now we were learning. Already we studied in microprocessor, the same concept only I am repeating, but you people have forgot. At least you have to remember. What is read operation? Where it is flowing, ma? Tell me. What is this? P1 is what? Bharat, what is
The
P1?
processor, ma'am.
P1 is?
Port to the processor.
Port to processor. Very good.
Processor.
Read means what? Port to processor. Write means what?
It write the
Vice
command
versa, man. Processor to
port.
port. Very simple. Processor to port. So this two operation. Why am I telling this operation? Huh? You can mute. My port one will behave as an input port as well as output port. That means it can receive the data as well as it can transmit the data. You all understand? Who's you have? Who is speaking, ma?
अरे नहीं सुन रहा हूँ, ये तो बोल रहा हूँ मैं. क्लास चल रहा है यार अभी.
Please kindly mute your mic, ma. I think most of them were put your switch on your video thing, and you people are listening. Okay. Now I will move on to port 0. Okay. I think there will be some question session. Port 0. Port 0 means you all know it have a dual role. Dual role means it will work as an input output port. Along with that, it will working as an address and data bus are multiplexed. MUX multiplexer. Okay. Balaji, register number 31. Hey, I will note down who are all not telling the answers. I am just note down the numbers. The same questions will be asked on Monday. You people remember Balaji?
Yes, ma'am.
Yeah, Balaji. What is multiplexer, Balaji? Mux they have written now. What is mux? Multiplexer. Multiplexer. Even you have a mobile with you, you can Google it and you can tell the answer. Okay, mute your mic. Multiplexer means what? Multiple inputs, single output. Can you understand? In the previous circuit, we don't have a multiplexer option. Why, Mona? That port 1 is acting as only a single purpose, but it is serving as a dual purpose. So my multiplexer means I am having two inputs. One is from internal bus and another from address and data line. So whether it should connected with address and data line or whether it should connected with internal CPU bus, that will be decided by MUX. So MUX, we have an option 2:1 MUX. Did you remember? 4:1 MUX, 16:1 MUX and all. So 2:1 MUX means only one selector line will be there. 4:1 MUX means 2 square. How many selector lines will be there? 2 selector line. Okay, 16:1. So 16:1 means 4 selector line will be there. 8:1 and 3 selector line will be there. I think I have taken a multiplexer for you people, but still you people have forgot. Okay, so what we have studied, that only we are applying now. No new concepts here. Only thing is, some persons have developed this microprocessor and we keep on studying what they developed. Can you understand? We are not inventing anything. We are just learning. Why we are learning this processor? Na? When you move on to any higher end of processor, you can understand very well. Because one instant that one person have completed CSE and he is working as a project engineer. Okay, but his son want to work with. We are know nowadays very popular is this all Android mobiles and all. So the student has to do some projects. So he has to do some project using Raspberry Pi. He can't understand what is Raspberry Pi. So You people have to know, at least you are the electrical engineer. I shoot out one question to you, how to rotate the motor in clockwise and anti-clockwise. You people can't understand. So even any new processor or new controller had come, you have to investigate. You can capable to investigate. Even you are not in this particular line, you are in some other line, you have some knowledge. Okay, that knowledge is very much needed. Then only whatever the new technology, new thing is adapted, you can able to cope up with that. Okay, so people, please kindly listen on that. So multiplexer na 2:1. So in this port 0, how we were having na, the same diagram is there. So remember, one is delatch, that is mandatory. Then one input buffer is needed, that is also there. Then output driver circuit is there. Fourth part is what? Multiplexer. Why multiplexer na? Whether I have to connect with my internal bus or whether I have to connect with my address or data line, that I have to decide. Okay. Then another question, at what condition it will connect with address and data line, and what condition it will connected with internal bus, that we have to internal bus means you have to understand it's CPU. That what condition it has to connected with address and data line, or what condition it has to connected with CPU, designed on the control line. Whenever my control is 1, that will connected with address and data line. Whenever my control is 0, my multiplexer will connected with the CPU bus. So here the same configuration like port 1, but additionally what we have more multiplexer. What is the purpose of multiplexer? To multiple inputs will comes to the multiplexer, but it will take only one output at a time. So whether this is switch, multiplexer is like a switch only, whether it can connected to address or data line, or whether it may be connected to the CPU, decides by the control line. Whenever my control is 1, obviously it will connected with address and data line. Whenever my control is 0, it will connected as a CPU and it will act as a bidirectional IO port. Are you clear? Okay, same operation. I think we don't have a time to discuss. Okay, people, okay, I can I have stopped sharing the video. Why? Because now I want to know whether you have understand. Today I have explained only port 0 operation alone. So port 1 operation, sorry, I have explained port 1 operation alone. So port 0 operation tomorrow, Monday we will discuss. So whatever I have taught till yesterday, I have put it in LMS. So in LMS, how I have put now, I have followed the PPT followed by introduction about embedded. You have to know why you are studying this subject. So if I have give a brief introduction on embedded. So I gave on first class itself what is embedded application, what is embedded development cycle, and in automobile, why, how embedded is used in anti-lock braking system, how it is working, digital camera, that and all I have put it. Okay, so nearly some 32 slides about introduction only, about embedded system. After 32 slides only, we were, so don't get afraid on that. You have some nearly some 10 to 15 slides only about this subject. Only this about now comparison, then pin diagram, then architecture, then registers. This and all we are seeing. So actually I have memory also. So comparison, pin diagram, architectures. In architecture only register will come. Okay, memory. So the 4 main topics I have put it up. So please listen, people. Actually, I am keep on giving the assignments and all for you people to understand, because we were going to face only multiple choice of questions. So you have to understand the topic only. You can able to answer for our questions. So it is not like that. Studying one diagram, writing something, and getting the marks is not like that. So here you have to know the concept, then only you can able to answer. Yes, anyone having the question, please ask question ma. So I will take the attendance from there. So listen, the previous classes, Python, whoever joined 120 minutes will be there. Apart from the students, whoever having, they should be having attendance of 60 minutes. These are not there. Definitely, I am not going to take your attendance. See, remember, whenever you are logging, and even you are multiple times you have login, that is also will generate as a report. So that's not a problem for you issue. So next class I will read out who are not present. Tyagi, and I have seen that some of them gave the attendance. Don't encourage that people, ask, inform to them. Okay. Now any queries there? Please kindly ask ma. Any queries? Students? Any queries? Harshavardhan? Yeah. Any doubts ma? Harshavardhan?
No, ma'am.
Yeah. No doubt. Okay. Shiva Subramanian. Register number 23.
Yes,
Shiva,
ma'am.
any doubt ma?
No, ma'am. No
You
doubt.
all understand well.
Ma'am?
Hmm?
Understand?
Okay. Understand. Very good. Akash. Register number 5. Akash.
Yes,
Have you
ma'am.
understand ma?
Yes, ma'am.
Okay. So people, now I'm leaving the meeting. Monday we will meet. Please kindly go through the slide. 33 slides about introduction. So to know about embedded, you see that. Then the remaining only our curriculum based. So see it that and go through it. Next class we will continue with the course. Thank you, ma. Thank you, students.
Thank you, ma'am.
Thank you, ma.
Thank you, ma'am.
Thank you, ma'am.